Welcome. In this video, we are going to solve some problems relating normal distribution. Here, we have three problems. I am just going to give the hints by which we solve the problems. Okay. Here, if you see, given that x is a normal with mean 4.8 and variance 2.56, and we are asked to calculate two probabilities. Okay, so how do we find it? We will just standardize them. So probability of x smaller than 3.4 is probability of x minus 4.8, that is mean, and variance. So here we have standard deviation, that is under root 2.56 smaller than 3.4 minus 4.8 upon under root 2.56. Okay, from this itself we are able to clearly see this is going to be some negative quantity. Okay, if you are using two-sided table, you can read the value directly from it, right? If you are using one-sided table, you have something lesser than negative quantity, so you will have to make use of the symmetry and calculate this thing. Okay, whereas in the second one, so that is to find the probability of 4.0 smaller than x smaller than 5.2. Here if you see, you will have 4.0 minus 4.8 upon under root 2.56 less than x minus 4.8 upon under root 2.56 less than 5.2 minus 4.8 upon under root 2.56. This is what we have. So here, what is the thing that we are going to have? We will have some negative quantity in this place and some positive quantity. Okay, in the previous video, I did not tell you how to read the values if we have, like, supposing we have probability of minus a less than supposing z itself I am writing, since anyway we will convert this to positive and negative things, like we will convert this to standard normal thing. Here a b are positive quantities. Okay, minus a to b, this one we will write it as probability of minus a less than z less than or equal 0 plus probability of 0 less than z less than b. Okay, whenever you are trying to find out the probability from minus some point to 0, this is same as that of the probability from 0 to a. Okay, so this just becomes probability of 0 z to a plus probability of 0 less than z less than b. This one you can make use when you are using one-sided table, like the table that is shown in this slide. Okay, so using that ideology, you can very well find out the probability in this problem. Okay, now coming to the second problem, the lifetime of a battery is a normal random variable with mean 3, which is given. Standard deviation, we are directly given with sigma value. What is the probability that in a sample of 5 batteries, more than one will fail in the first year of use? Okay, so lifetime is something like this. Okay, and we are asked to find out the probability that in a sample of 5 batteries, more than one will fail in the first year of use. How do we do it? Okay, so first of all, here our random variable is going to be what? Okay, so let me name the questions as 1, 2 and 3. Now we are trying to solve this 2, isn't it? Okay, so our mean is 3, standard deviation is 1.2. Okay, we need to find out more than one will fail in the first year of use, right? So one minimum one should fail, to the maximum 5 can fail, right? So this is what we are going to find out. So probability of 1 minus 3 upon 1.2 smaller than, when you make the changes, it becomes a standard variant. 5 minus 3 upon 1.2. So it is going to be probability of minus 2 upon 1.2 less than z less than 2 upon 1.2. So if you are using like you can very well make use of the table that is available to you, with which you can very well find out the probability. Okay. Now coming to the third problem, x is given to be a normal random variable with mean 62.4. Find the standard deviation of x if the probability is 0.20 that it will take on a value greater than 79.2. Okay, let me put them in the wordings with notations. Mean is given to be 62.4. Okay, probability is given as 0.20. Okay, and the x value is greater than 79.2. So probability of x greater than 79.2 is 0.20. Okay, this is same as that of probability of x minus 62.4 divided by sigma, that is the standard deviation which we need to find out, which is greater than 79.2 minus 62.4 upon sigma, which is equal to 0.2. Okay, that is probability of standard normal variate z greater than some quantity. Okay, for simplicity purpose, let me take it as z1, which is equal to 0.2. Now we have greater than. Okay, let me write it as probability of 0 less than z less than infinity minus probability of 0 less than z less than z1 is given to be 0.2. Let me write it this way. Okay, there is no harm in it, right? Okay, now I know this value is 0.5 minus some quantity is 0.2. Now I need to find out this z1. Okay, this is what I need to find it out. Okay, we can okay, if now that we know the okay, if we just convert all these things, probability of 0 less than z less than z1, this comes to this side and this would be 0.3. Okay, now you come back to the table. Here if you see, I am calculating the probability from 0 to z1 and that is 0.3. Now we are coming back to the table and we are looking for the value 0.3 inside the table. There is no guarantee that we will get it exactly. If you see here, we have 0.3023 and here it is 0.2995. So between these two values, that 0.3 is going to lie. Okay, this value corresponds to 0.84 and this value corresponds to 0.85. So we just take the average of these two if the required value is lying between these two things. Okay, we don't have to care too much whether it is closely related to this 0.84 or 0.85. Just take the average of this thing, so we would get 0.845, right? So coming back here, from this what you get is your z1 is 0.845. Now in your z1, if you look at, it is 79.2 minus 62.4 divided by sigma as 0.845. Now that you need to make some calculation and find out the value of sigma. That's it. Moving further, we have a problem. Here it says that we are asked to find out the value of k as a function of mu and sigma such that this is happening. Okay, so probability of x smaller than or equals k, which is same as that of thrice the probability of x bigger than k. Okay, let us have this one as it is. Okay, now let us standardize it. Okay, or before standardizing, let me have this one as it is, greater than k. This means I can write it as 1 minus probability of x less than or equals k. So that now I don't have two different quantities, I have the same quantity on both the sides. Okay, if I bring this to this side, I get 4 times of probability of x smaller than or equals k is 3, right? So probability of x less than or equals k is 3 by 4, in which I just normalize it x minus mu divided by sigma less than or equals k, which is equal to, less than or equals k minus mu upon sigma, which is equal to 3 upon 4. Okay, so what we have is probability of z less than or equals k minus mu upon sigma is 0.75. Okay, it is 0.75. So if we have some probability which is more than 0.5, we split it as 0.5 plus the extra quantity. So this 0.5 is covered in this region. Okay, if we are using one-sided table, we have the region in the right hand side only. Here I am using this one-sided table. Okay, 0.5 is covered in the left side region. Now I need to look here. What should I look? Only 0.25. I just look for this 0.25. Okay, so it is somewhere between these two values. Okay, it corresponds to 0.67 and 0.68, so 0.675. I approximate it as 0.675. Okay, this tells me that my k minus mu upon sigma is 0.685. Okay, isn't it? Okay, here we are given with the values of mu and sigma. Okay, k is 0.685 times of sigma plus mu. Substitute the values of sigma and mu, you will get the value of k. Right? Now we have another problem. Here it is said that assuming the diameter of 1000 plugs taken at random follows normal distribution. So the assumption is completely fine. Okay, with mean 0.7515 and variance is accepted till 0.0002 square. Okay, how many plugs are likely to be rejected if the approved diameter is this quantity? Okay, so this is the limit that we accepted. If it is below this quantity or above this quantity, we just reject it. Okay, so from this we try to identify the accepted range. Okay, so just a minute. I think, okay, so it is 0.752 plus or minus. Okay, that is a typo in the question. Right, so these are the given informations. If you add this plus 0.004 with this quantity, you get this one and this one. So these are the limits. Whenever you okay, if your limit is lying between these two things, you will accept it. Okay, whereas in the question we are asked to find out the probability, okay, number of plugs which are rejected. First of all, let us identify the probability of acceptance. Okay, we have this one, and also we have the mu value and sigma value. We standardize it. Okay, the standard variables, like if you calculate the standard variables at the left and right, you get these two values. Okay, now after standardizing, you calculate the probability and that comes as 0.9477. Right, now that it is the probability of accepting one sample. Okay, now that you have 1000 plugs of that kind, just multiply 1000 with those quantity, that gives you 948 plugs, which means you will accept 948 plugs. Therefore the remaining we will have to reject them. So we are rejecting 52 plugs. Thank you.